Now let us do next sum, that is question number 13, very lucky one. See, before we go for this, let us understand this. If a church Q1 is brought in contact with another church Q2, suppose they are connected by a wire, then there will be a charge distribution between them till their potential, that is voltage, becomes equal. We will be doing this just in the next chapter. But till now, let us understand one thing. If they are of equal size, then both will acquire equal amount of charge. And that would be how much? Simple average of them. That is Q1 plus Q2 by 2. That is the rule. We will understand this. Now, let us apply this. Let us come to this sum. Same sum in the last question number 12. Last question. Same charges are there, 50 centimeter gap. Now there is another uncharged body, suppose C. It is uncharged. That means its Q is 0. Q of A be given. This is brought in contact with A first. So what will happen? This thing will happen. So then charge of Q, charge of C, I am writing here. Let us draw A and B again. A has a new charge QA dash equal to 0.6, 6.5 into 10 to the minus 7 by 2. Let us write this like this. This much. Why? Because C will be having this much of charge, A will be having this much of charge. How much? This plus this by 2. So 0 charge of C plus this divided by 2. That is 0 plus this by 2. A will retain, and this much of charge, same amount of charge, C will now retain. So now C has a new charge of, I am drawing C here. C also has 6.5 by 2, 10 to the power minus 7 coulomb. C is also having this much of charge. Now it is given that C is brought in contact with B. Now if C is brought in contact with B, B was having same charge because it had no change, this much coulomb. So what do you think what should happen? There would be again charge exchange between them. Again according to this formula, Q1 plus Q2 by 2, that would be the new charge. So how much that would be? This plus this by 2. No need to calculate them. Just think like this. So it would be, say, if this is 6.5 10 to the power minus 7, suppose x. So may we tell that this is x by 2? If this is x, this is half of that, x by 2. So charge on each, Q each, after charge distribution would be x plus x by 2 by 2. How much would it be? 1 plus half means 3 by 2. Then by 2 means 3 by 4. So can we write it as 3 by 4x. So charge on each would be 3 by 4 into x. That means charge on each would be 3 by 4 into x means what? This much. 6.5 10 to the power minus 7. This would be the charge, new charge on C, and this would be the new charge on B. So now final thing happens like this. A, blue, becomes black now and has a charge of this much. So let us write in terms of x only. A is how much? X by 2. B is how much? 3 by 4x. Now if the distance remains same as 50 centimeter, now it has been asked in the question what would be the new force between them to calculate that. Simple. F equals to K. If initial charge of A and B were x each, then initially the force was between them was initially K x into x divided by r square. We calculated that value. That was something around last question, 1.521 into 10 to the power minus 2 Newton. So anyway, this was their initial charge, initial force between them when they were having charges like this. Now they are having charges like this, initial charge by 2, initial charge into 3 by 4. What would be the new force? Just as we did in the last sum, K x by 2, 3 by 4x divided by same r square. You need not to calculate this. Just see this. K x square by r square into, think of the factors. The factors are now this and this. So into 3 by 8. This was the initial force, that is this much, into 3 by 8. So the force would be, initially it came out to be 1.5 to 1 10 to the power minus 2 into 3 by 8. That's it. No calculation required. Only this much. Last line. I think you can do this. Simple. See this. Question number 14. डरावनी पिक्चर्स कुछ है नहीं वैसे. नोटिस करो ऐसे. First thing, 3 charged particles, 1, 2 and 3. They are projected along the same direction simultaneously. So they are projected along which axis? X-axis. Along y-axis, the velocity is 0. No velocity along y-axis. First, the second thing, these will always have an electric field. We have done theory on this, from plus to minus. This electric field will create an acceleration given by force by mass, that was EQ by m. This is the acceleration. That means they will continue moving along this and simultaneously they will accelerate in this direction. Which charge? Positive. Positive charge moves along the direction of electric field, but negative charges move opposite to the field. Which charge or charges here are moving along the direction of electric field? That means downward. Only charge 3. So charge 3 is of what nature? Positive. Otherwise, you can well understand, positive charges will be attracted towards the negative plate and negative charges will be attracted towards the positive plate. So these two charges obviously are negative. Only third charge is positive. That was the first part of the question. Second part. As these charges are moving along x-axis, initially they had 0 velocity along y-axis. So along y-axis, their initial speeds were 0. Now, suppose from their respective positions here, suppose let us take the first one here. It is its initial level of motion. From this, whatever distance it has moved along upwards direction, that is this distance, this distance, this distance, these distances. These are called SY. So S is given by, first you have to think whether it is uniform velocity or accelerated. Accelerated. So S would be UT plus half AT square. We can see that U along y-axis initially was 0. So this part becomes 0. So may we write that SY equals to only half AY into T square. Half, what is the value of AY? EQ by M into T square. T is the time taken to move up to this position, up to this. So if S, that means displacement along y-axis is this much, so which particle will displace more or less can be given by this. S is proportional to Q by M. Why? Because half is a constant, electric field is uniform, that means constant, mass of all the three charged particles are same, that is constant, they have moved for same time. Sorry. Mass is not same. Mass is given as M. So we will keep mass as a variable. So Q and M are variable here. Half is constant, electric field being uniform constant, time of movement of all the charges is constant. So Q by M, SY is directly proportional to Q by M, charge to mass ratio. That means more the value of Q by M, more will be displacement along y-axis, SY. So displacement along y-axis has been maximum for this charge while coming out of the plate. Notice one thing, out of the plate, all the charged particles are moving along straight lines. But inside the plate, the motion is parabolic, I told you once. Anyway, so this has got maximum SY, this has got minimum SY, and this has got moderate value of SY. So maximum SY, that is deflection, is for third charge. So third charge should have maximum value of Q to M, that is Q by M. That is the answer.